All right, all right. Welcome to the next latest and greatest webinar on CIS-211. I am Professor Lusby here at GMC, and we are starting a brand new term on Principles of Computer and Programming 2. And you're going to see that we're pretty much going to pick up where we left off on CIS-210. We basically covered the first half of the textbook in CIS-210, and now in CIS-211, we are going to cover the second half of the textbook. And you're going to see that, yeah, we're going to get into some more advanced topics than what we covered in CIS-210, and we're going to get into a lot of the fun stuff, is what I like to call it, a lot of the industry relevant stuff that they expect us to know. All right, so with that said, I did create an introduction video that I posted at the top of the classroom here. If you haven't had a chance to watch that, please do. I go over a lot of the important links at the top of the classroom and what those contain. But just a quick recap, the important links being this news and announcements. Obviously, I post at least once a week, but in week one, much more frequently, probably daily. So please always check that news and announcements link as you log in each day. I think you're supposed to get an email anytime I post an announcement. Can you, those of you in chat that is attending, can you confirm that you're receiving emails concerning these announcements? That would be good to know. But what else? What else is important? Oh, yes. Okay, thank you for confirming that. So yes, it does look like those announcements are being emailed out to you, at least currently. The other important link is this handy dandy, wonderful virtual desktop that we all have come to know and love, especially in CIS-210. It has everything installed that we need, including a Java IDE, in this particular case, NetBeans, the proper JDK, as well as JavaFX. And you're going to see that we are going to use JavaFX quite a bit more than we did previously. So make sure you watch that introduction video as far as how to access the virtual desktop. And depending on what kind of computer you have, Windows PC, Chromebook, MacBook, these are the documents that explain how to access this virtual desktop. All right, what else? What else? What else? All right, for the discussions, the textbook activity framework files are here, and I'll show you how to access and use those as needed with each week. So we'll circle back to that. Please make sure to introduce yourself, right, in the introductions discussion forum. A lot of you have already started to do that, and that's great news. I see a lot of familiar faces from CIS 210, so that's really good news. Right, probably the most important thing during week one is this participation in academic honesty verification. You need to complete it within the first 4 days or risk automatically being dropped. So for sure, we're on day 2 of the term. If you haven't done this yet, you want to do this ASAP in order to avoid being dropped. All right, finally, so now we get down to week one, and we've got a lot to cover here, so I'm glad that we're talking about week one already. I basically want to go over what it is that week one entails. If we click on this overview and objectives page, we're going to see that with week one, we're going to talk about multi-dimensional arrays, right? The last week of CIS 210, in chapter 8, we talked about single-dimensional arrays. Well, now we're going to talk about multi-dimensional arrays, and multi-dimension has many meanings, but one of the most common multi-dimensional arrays used in industry is a 2D array that basically looks like a spreadsheet where we have rows and columns, and you're going to see some good examples in chapter 9 of your textbook concerning different 2D arrays. What else? Yeah, they're going to go into a class called an array list that is a little more flexible than just a 2D array, but we're really going to focus in on that 2D array. Okay. And all of this is described in chapter 9 of your textbook. If we take a quick look at that, yeah, we see that the title is multidimensional arrays and the array list class. Make sure that you read over this material and get familiar with it. Obviously, it's going to help you with the discussion and the programming assignment, but you're also going to be tested or quizzed over that chapter 9 material. So yeah, for sure, look into this. And I believe that for the discussion this week, we're going to look at programming activity 1, which is where we are working with, as I mentioned, those two-dimensional arrays. And we'll circle back to this here in just a second. All right. There are some optional or supplemental learning resources listed here. A link to more information about this Java array list that we're going to hit very lightly, but definitely some more information here on the two-dimensional array. Some students find this useful, some students find this confusing. Always, I mean, at the end of the day, always go back to the textbook. And if you're confused with the information in the textbook, that's why I'm here. Please reach out via email so that we can start a dialogue, and I'll see if I can provide some further feedback to help. Also, there are some PowerPoint slides available. Some students find those useful to help study for the quiz or just get to know some of these high-level concepts better. By all means, feel free to download the PowerPoint slides for Chapter 9 as well. Okay, but all of this is supplemental / optional. It's up to you if you want to review it, use it, etc. All right. So what's the nitty gritty for week 1? Very similar to CIS-210, we have a week 1 discussion where we are usually creating or completing a programming activity from the book. We have a week 1 programming assignment where you do need to create some code from scratch. And we have a week 1 quiz. So those of you that took CIS-210 with me last term, all of this should look very familiar. All right, so what in the heck do we need to do for the week 1 discussion? If we look at the week 1 discussion, we will see that they want us to complete programming activity 1, working with two-dimensional arrays. And again, they say once you've completed it, answer these questions. But again, if you've spent quite a bit of time on this, trying to solve this, and it's Wednesday, and well, for week 1, you have until Friday to complete the initial post. But you know, don't be afraid to post after you've spent a significant amount of time trying to find the solution, right? The discussion is concerning this particular programming activity, but you can call out what it is that you're stuck on, or what particular line of code is giving you a syntax error. That's what this discussion is about, as well as some high-level questions concerning other topics that are in the chapter, in particular this array list, or maybe multi-dimensional arrays. Lots of good stuff in chapter 9. Please try to answer these questions concerning the programming activity, as well as those different topics. So lots to talk about. No reason you can't come up with 150 words usually by Wednesday. This week is by Friday. And make sure you respond at least 2 of your peers for full credit concerning the discussion. So how do we go about completing programming activity 1? Well, I'm glad you asked. We should go to our handy dandy virtual desktop, right, which is located towards the top of the classroom here. Go ahead and launch the virtual desktop, and you should see something that looks like this. And on it, or in it, is the Java IDE or NetBeans IDE that has already been installed and ready to go. So in order, well, first let's take a look at what in the heck is this programming activity? And it is listed here in section 9.5. So if we click on that, we'll see that, yeah, it's another kind of pre-made program that is supposed to demonstrate how 2D arrays work visually. And so when we import these files and when we run these files, and I'll show you how to do that here in just a second, we should see something that looks like this, where it's showing us the contents of a 2D array, and it looks to be 4 rows by, oh my gosh, I don't know how many columns, maybe 20 columns of information. And then they show us little graphs above each row to visually represent the magnitude of all these different values. All right. And eventually, we need to write methods that perform these 5 operations here. All right. And these 5 operations: fill the array, print, set every array element, find minimum, count the number of elements, correspond to these 5 buttons here. So when we click on one of these 5 buttons, it should call the code that that's associated with each of these 5 operations. All right. Okay, so how do we do this? How do we implement this program using the virtual desktop? Well, I'm glad you asked. We are going to go into our virtual desktop, launch NetBeans, which we should be used to from CIS-211. And we're going to come up here and go File, New Project, just like we always do. Java application, okay? Give it a nice descriptive name, 23, what's this, spring now, huh? Space EMP, CIS-211, and we are trying to accomplish the week 1 discussion. Give it a nice descriptive name, keep the project location as is, right? It is a path that has read and write privileges for you. Please don't change this. You'll get all sorts of weird errors in the virtual desktop. Make sure this is unchecked. Make sure this is unchecked, because we have the textbook supplies the files that we need. All right. Once all of this is done, go ahead and click on Finish, and we should see a nice empty project. And at this point, I would say go into Chrome inside of the virtual desktop, go into the classroom inside of the virtual desktop. How do you get to the classroom? Please type this URL in directly. If you try to get to the classroom using the main GMC page, I don't know why, but the virtual desktop just doesn't like it, and it sits there and spins forever. As long as you type this in directly, you can click on the login button at the top here, and you can get to your classroom. All right. Make sure you do that inside of the virtual desktop. Why? Because inside of the classroom, inside of the virtual desktop, we're going to come down here to this link right here. We're going to click on this, and this has a zip file that contains all of the source code that we need. All right. And if we open up that source file, we're going to see chapter 9, programming activity 1. All right. And again, if I'm going too fast, please pause the recording, pause the video, and kind of rewind a little bit, or maybe just try to do the same thing and then hit play again. All right. Here are all of the files that we need. All of the Java files, all of the FXML, well, the one FXML file that we need. Perfect. So what do we do now? Well, now we go back to NetBeans. All right, we've got our empty project. We're going to pull up File Explorer that contains those files. We're going to highlight all of those files, right? Hold down the left mouse button and draw a big square over them, or rectangle. Highlight all of those files. Hold down the left mouse button and drag and drop onto the default package and release the left mouse button. All right, that will basically import all those files that we need for the Chapter 9 Week 1 discussion. All right. Once we're here, I believe it's here in the practice controller, and it calls it out here somewhere. It tells us, yeah, 2dim array practice controller. We should see these 1, 2, 3, 4, 5 methods that we're supposed to implement. And they are, here it is. Here's 1, here's 2, here's 3, here's 4, here's 5. All right. So they do expect us at this point to be able to come up with the solution. And they do give us some pseudocode here that should be very helpful. You know, in theory, you should be able to take this pseudocode and convert it into actual code. Obviously, some of you have found the solution, some of you have not. And what I want to do here is show you at least one possible solution for these 5 parts that we're supposed to implement, because each one of these 5 parts is very important. Knowing how to fill the values inside of a 2-dimensional array, super important, because we need to initialize the 2D array to some values. Knowing how to print all of the values in the 2D array, super important. We need to know how to display that information to the user. Knowing how to set those values, again, super important. Finding the minimum. For industry, this is very important. And being able to search and count how many times a particular item is in that 2D array, also super important. So instead of boring you with me sitting here typing in the solution, I went ahead and did that prior to this webinar, and I would like to show you that solution now. I know it's a little early in the week, and maybe some of you haven't had a chance to do this yet. So I guess if you want to, you can kind of fast forward past this part or pause or do whatever you want to attempt it. But regardless, it is important to talk about at least one potential solution, because when we're learning how to code, well, seeing at least one solution is worth, picture's worth 1,000 words, right? And knowing how to read and interpret that code is just as important as writing the code itself. I would say we need to learn how to read code before we can write code. So let's take a look at least one possible solution for this week's discussion. And we're going to see, well, the fill values was already done for us. They did want to give us an example of how to access a 2D array. And typically, that utilizes a nested loop, right? A loop inside of a loop. Why does it have a nested loop there? What do you think, chat? Why is there a nested loop for a 2-dimensional array? All right, and I wish I could pause longer, but I've just got so much more material. I was trying to make this interactive, but it's just going to be so hard because of the amount of material that I need to cover today. And the answer is that we need a loop for all the rows, and we need a loop for all the columns, right? Because if we look at this data, we see that all of this data is contained in different rows, and each row has a set amount of columns. So what the nested loop is responsible for the columns, the outer loop is responsible for the rows, and that is exactly what we're seeing here. Okay, the outer loop is basically counting over all the rows, the inner loop is counting over all the columns. And the reason that's necessary is because fill values wants us literally to set each and every value inside of that. I would call it a spreadsheet, right? It's literally a spreadsheet. Here's your rows, here's your columns. It's just the columns aren't labeled A, B, C, D like we're used to in Excel. They're just an index, 0, 1, 2, 3, all the way up to, I don't know, is it 20? Well, we can find out. What does it say up here? Yep, rows is equal to 4, columns is equal to 20. All right, so the outer loop is the row that's going to go from 0 to 4, well, 0 to 3. And the inner loop is going to go from 0 to the row length, which is basically 19 for a total of 20 columns. And here, this is the important part, right? So in CIS-210, when we learned about single dimensional arrays, we used one pair of square brackets to call out where in that array we were interested in accessing. When we're talking about two-dimensional arrays, we have two sets of square brackets, not one. All right. And the first set of square bracket calls out which row you're interested in. And the second pair of square brackets calls out which column that you're interested in. So when you have a 2D array, you need two pairs of square brackets, not one. And not only that, the ordering matters. The first one represents the row. The second one represents the column. You don't want to swap these two, or you're going to get some really weird results. All right, the first array, or excuse me, first index is always row. The second index is always column. And you can set it equal to a value, just like you can using the single dimensional array. Okay. And in this case, it's just randomizing a value between 31 to 50, between 30 and 50, or between 20 and 50. No, 30 and 50. 30 and 80. Excuse me. Yeah. 30. I definitely see 80 as the max, and I believe you could do 30. Anyways, it's a random value. Let's just put it that way. Okay. And once we set each one of those, let's call cells in the two-dimensional array to a value, we call animate. And animate basically does some blinky lights on the GUI to show us that it's being set to a particular value. All right. So fill values is this code here is a really good example of how to access all values in a 2D array using this for loop inside of a for loop using these columns and rows. All right. So why they did that was because the next part here, print array, well, here we want to display all or call animate for all of the values, well, and print apparently. And very similar to filling the values. Well, we need two for loops, one that represents the row, one that represents the column, and we can use that row and column and the 2D array variable name in order to access each one of those values. All right, that's the beauty of arrays. At the end of the day, the beauty of arrays is we can use some sort of counter in order for that counter to become the index of the array in order to access every single value inside of the array, right? If we have 100 values and we have an array, well, we can have a single variable name for the array, and we just need to create a counter that goes from 1 to 100, let's say. You know, the alternative, I mean, imagine life without arrays. We would literally need 100 unique variable names. Imagine what this code would look like, trying to print out all 100 values with 100 unique variables. It is absolutely ridiculous and atrocious, and I hope you never have to do that. All right, or let's imagine your Google or Facebook with 1 million or 1 billion records that need to be printed out. All right, an array is a very efficient way of accessing information using an index, a numeric index value. And a 2D array has two index values, one for row, one for column. So this allows us to print the array. Then it wants us to do something called set values. Well, set value isn't a very descriptive name because when you dig in a little bit, it wants you to set the values for one particular row, right? It wants you to take this value, this first parameter called value, and set every element in this row to this value. So what they're demonstrating here is that, well, we don't really want to access all elements in the 2D array like we did for the first two functions up above. We just want to access one single row and every element inside of that row. So in this case, where we're just accessing one of those rows in a 2D array, we're just going to have one for loop that's going to start at 0, right? Because the only thing that changes in that row is the column. And the column goes from 0 to however many items are in that row, which we can figure out using this dot length guy that is called out in the textbook. Okay, I suppose we could also just call out and say 20 here, because we know that there are 20 columns in every row, but that's not very, well, what happens if somebody goes up to the top and changes the number of items in each row? Well, then the code's going to fall flat on its face if we hard code 20 here. So this dot length enables us to have maintainable code that allows us to change the size of the array or the two-dimensional array if we want. All right. But the important point here is that there's one for loop because we're only interested in one row. So we have a for loop that's going to go through all items in a single row and basically set each one of those items in that specific row, right? Each one of these items in that specific row to whatever value is passed in. Why are we doing this? It's just for demonstration purposes. Does this really have any real value in the real world? I don't know. Do you ever really want to set all values in a particular row to a particular value? I guess maybe, but to my knowledge, that doesn't happen very frequently. I think they're just doing it to force you to use a single loop to look at a single row. All right. So here is how it demonstrates that. Now, this is definitely used in industry. And this is basically a find minimum value algorithm. And I don't care what language you pick, what data structure and algorithms course you go to, they all look like this. And there's a few very important parts to this find minimum algorithm. First is that you always initialize the minimum to the very first item in the array. In this case, notice that it wants us to find the minimum of a particular column, right? Before, we were setting the value for a very particular row, and we had this. Now, we're wanting to find a minimum value for a particular column. And the key to a find minimum algorithm is, for sure, the very first thing is you want to set the current minimum value to the very first value of that, let's say, row or column, depending on what you want to look at. All right. The next thing you want to do is you want to loop through all of the elements in that column, which is what this for loop does, and say, well, hey, ignore this for a second. If the value at that particular row and column location is less than the minimum, this is the next important part. Well, guess what? The new minimum is the value at that location. So those are the three important parts of a find minimum algorithm. Number one is initializing it to the first value in the array. Number two is looping through all values in the array. And number three is looking to see, hey, is the current value that I'm at in the array less than the current minimum? And if the answer is yes, we'll make that the new minimum. All right. And once this loop is completely done running and looking at all values in that, well, in this case, in that particular column, well, then when it's all done, then that minimum variable is going to be equal to the smallest value that it's seen in that entire column. All right. Now, What if this were find maximum? Well, instead of minimum, we call this maximum. And instead of less than here, we would use greater than. All right. So find minimum and find maximum value algorithms. It's essentially 4 lines of code. But they need to be done in the proper order using the proper for loop, looking for the proper condition. All right. This is find minimum, find maximum is a very powerful algorithm that is used quite a bit in industry. All right. And I believe they also call it out in the textbook as well. All right. So that's find minimum. And then count found. Well, this is basically a search algorithm, right? Well, if I'm looking for this value, right, we got all these values here. If I'm looking for, I don't know, 61, how many times does 61 appear? Well, you got to go through all of them looking for 61. And in this case, for 61, it found 1, 2, 3, 4 instances of 61. It's a searching algorithm. So how do we implement that searching algorithm? Very similar to up above where we displayed all the values, or what was the other thing we were doing? Printing all the values or filling all the values. We have a loop inside of a loop. Well, same with this count found. The searching algorithm, we have a loop inside of a loop. Why? Because we're looking at all elements inside of the 2D array, and we're saying, well, hey, is the value at that row, at that column, equal to the value that's passed in? Did we find that value? And if so, right, if this is true, we're going to execute the very next line of code, which basically executes num plus plus or increments num by 1. Remember, plus plus is shorthand for num equals num plus 1. Why they did that, I don't know. All right. All right. So the reason I point all this out and the reason why all of this is important is because you're going to see when we get to the programming assignment, you need to do very similar things for your programming assignment. And these are all good, what I like to call frameworks or algorithmical frameworks, that's a big word. These are all good algorithms that will help you accomplish the requirements for your programming assignment. So for sure, I wanted to make sure that you have at least one possible solution for each of these 5 methods, because you're going to need something very similar for your programming assignment. Okay. Whew. Okay. That was a lot, but all right, enough about that. Let's go back to the classroom, shall we? All right, so your week 1 discussion forum, I showed you how to create the project for that, add the files, and one possible solution for each of those 5 parts that we needed to at least attempt to do and find a solution for. All right. What in the heck is the week 1 programming assignment? Well, I'm glad you asked. Guess what? It's using a 2-dimensional array. Notice that the information they give us is, well, it's NOAA information. NOAA basically is responsible for the weather research, at least for the US. All right. And they basically recorded wind speed and temperatures for 10 days, right? So we've got, day 1 was 12 mile per hour wind and 65 degrees Fahrenheit. Day 2 was 23 mile per hour wind and 73 degrees Fahrenheit, all the way down to day 10. All right, so we have 10 days worth of information here that need to be stored. And one possible way or one possible data structure that can store this information is a 2D array. All right. So they want us to write a program that's going to store this information into a 2D array. And once we have it stored, it wants us to calculate the top wind speed, the minimum temperature, and then display basically well, display the following output. And the following output consists of all of this. When you run your program with this data, it should access the 2D array and come up with all of this information. Do not hard code this information directly into your program. That defeats the whole purpose. Don't do a bunch of print line statements where you're just printing this information out. The whole idea is that your algorithms for these methods can figure out this data on its own by looking at this 2D array. Okay. I had a couple submissions a couple terms ago where students were just hard coding this as output. And it's like, well, no, that doesn't make any sense. All right. All right. So how do we go about, right. And we need these 5 methods implemented that's going to look at this 2D array's worth of data and come up with this output. How do we go about doing that? Well, I'm glad you asked. Let's launch our handy dandy remote desktop. Let's launch NetBeans. All right. Let's create a new project. This should feel very familiar by now. Anytime we're doing a new program, absolutely, we are creating a new project. Java application. Let's give it a nice descriptive name. Oh, what is this? SPCMP CIS-211. We are in week 1. This is the what? Assignment. All right. Sure. Well, first of all, leave this as is. Leave this unchecked. Make sure this is checked. I say get rid of all this package information that might be useful in industry, but we're trying to keep things as simple as possible in this course. So get rid of all the dot names before the actual class name and simplify your life. All right. So that looks good. Unchecked, checked. Nice, simple class name, no packages. Click finish. And we'll see that it creates a brand new class for us with a main method as always. Exciting stuff. What's next? Well, we come back here and look at the requirements. Does it specify what the class name? Aha. Class name is supposed to be NOAA weather data.java. All right, so it's not called NOAA weather data. How do we fix this? Well, if you remember back from CIS-210, what we can do is right click here, say refactor, say rename. Oh no, I've already forgot the name. NOAA, what was it? NOAA weather data. NOAA weather data. Apply rename, looks good. Hit refactor, bada boom, bada bing. We have our NOAA weather data class with our main method. All right. All right, what else do we need to do? Well, before this webinar, I created a guidance document because I don't want to bore you by typing in a bunch of comments. So I did exactly what I just showed you, created the project, right? Created the class, renamed it to NOAA weather data. And then, yeah, all right. Here's what I came up with. This is your guidance document. Please include, obviously, important information at the top, including the class, assignment, author, maybe even the date. That's always good. Obviously, this is you, not me. And oops, forgot to rename this. Please hold. Rename, factor, bada boom, bada bang, done. All right, so here's the main method. Obviously, the requirements call out, we need to use a 2D array. This is one way to initialize a 2D array with information. So, for instance, if day one is 12-mile-an-hour winds and 65 degrees Fahrenheit, well, we can change this to 1265, right? This is day one. This is the wind speed. This is the temperature. Obviously, you need to fill in the rest of these to be the correct values here. All right. This will create a 2D array called weather data that contains integer values. All right. Now, what else do we need to do? Okay, well, here's our 2D array data structure that contains all the data once it's properly filled in. Well, they want us to create a method, right, called display data that shows us all of this data in a nice, neat format that looks like this, right? The output of displayed data should look like this. So that's why I say, all right, fine, let's call display data to display the weather data. And notice that I've declared this display data method down below. And this display data method, a couple things about it. Number one, since we're calling it from a static main method, static has a way of, once you declare one method static, any method that's used inside of it also has to be static. So you're going to see that it has a cascading effect. That's the word I'm looking for. So if you're calling it from main and it's static, well, guess what? This guy's got to be static. This guy's got to be static. They all need to be static methods, just because the first one was static. And when I first started working in industry, that used to drive me crazy. But at the end of the day, static means that there can only be one, and it just has a cascading effect. All right. And I really wish we had more time to go over why and what that really means. But just trust me that all of these methods need to be static because they're being used from static void main. All right. So that's why this static word is here. But the other important part is that we're passing in this 2D array as a parameter. Okay. We don't want to make this a global variable. Global variables, you know, in CIS-210, it's kind of like, whatever. But once you hit industry, global variables are evil. They are bad. And you always want to pass whatever data is needed as a parameter. There are a few exceptions to that, especially with embedded applications, low-level applications. You want to create global variables, but at the end of the day, they're never good. They make your code very brittle, untestable, unscalable, undebuggable. Global variables are always, always, always bad. So at least for this course, I would encourage you to use parameters to pass in your information, not global variables. So that's why you see display data, and we're passing this parameter so that we can pass this weather data to the display data without making it global. All right. And it also fits the IPO paradigm, right? Here's your function. Here's the input. Here's the process. Here's the output. Now notice the output, the return value is void. So there is no real output because we're printing everything out to the screen. So by printing everything out to the screen, that is kind of our output. All right. But, all right, back to high level. We're calling display data. This display data is going to call this function down here. And here is some pseudocode to help you implement this function. I do expect that you can read this pseudocode and convert it into Java code, into working Java code. All right. And so I've kind of laid out a template as far as how, you know, what this function should do at a pseudocode level. And I need to know that you can take this and translate this into Java code. All right, so that's the display data. should eventually look like this, and it should be contained in a function that looks like this. Then main calls top wind speed. Well, top wind speed is going to transfer control down here, pass in that same 2D array called data, and the top wind speed should do something, right? At least this is one possible solution, right? Is this the only solution? No, but it is one possible solution that should work. I need to know that you can translate this into Java code. All right, it's basically going to take whatever that 2D array is, create a variable, right? Remember those three things I was talking about with that maximum value algorithm from the discussion, right? Set the max wind speed to the first wind speed on day one. Next, create that loop. That's the second part that I said was important. That loop's going to go through all rows of data using a counter called row. Once you get to that row and you check the wind speed at that particular location in that row, if it's greater than the max wind speed, well, guess what? Go ahead and set max wind speed to whatever that value is. You found a new max wind speed, so make sure that you set it there. And if you do these 4 lines of code and you wait for that loop to finish, right? Once the loop is finished, then return whatever that max wind speed value is, and that is the maximum value that the max speed algorithm found. All right. Here, minimum temperature, right? Well, what else do we need to do? Well, we need to call minimum temperature. Why? Because the requirements say right here, you need to have a minimum temperature, and the output shows us the minimum temperature. Well, once we call min temperature, same thing, pass in the 2D array. And here, look, it looks almost identical to the max value algorithm from here. The only difference is we're renaming max wind speed to min temperature. And here, instead of looking for a value greater than, we're looking for a value less than min temperature. And if we find it, well, we set min temperature to whatever that new temperature is. All right, and then once all this is done running, we return whatever min temperature is. And notice that min temperature is an int or an integer. The return value should be an integer. The temperature should be an integer. Same with wind speed. We return an int or an integer. The wind speed should be an integer. And it is, right? All of these are integers. So that should be no problem. And then lastly, return average wind speed. Why? Because the last thing that the output should tell us is the average wind speed. And that algorithm, one way to do it is like this, where you're going to have a total wind speed variable. You're going to initialize it to 0. You're going to loop through all the rows of that data, right, of that 2D array. And you're basically going to grab whatever that current row's wind speed is at row 0, because 0 is the wind speed, and you're going to add it to total wind speed. And then once this loop is done adding all these values together, then you can calculate the average by taking total wind speed divided by the total number of days present. Well, there's 10 days present. So you're literally going to take total wind speed divided by 10, and that is going to give you, looks like 15.9, or it should anyways. All right. Once you have that average wind speed, well then fine. Now you're going to return that average value, not total wind speed, but the average wind speed on the next line. So we're going to return a double or a value that includes a decimal point that represents the average wind speed. So obviously you're going to have to change these zeros to whatever the name of the variable is that you're using in these methods. Okay, so whew, that's basically it, right? That is, well, let me verify. Oh, the quiz. So for the end of week 1, don't forget your quiz, right? something like 10 questions, 4 open response, 25 minutes, 1 attempt at the quiz. All right, so make sure you're very familiar with chapter 9 before you take that particular quiz. And then obviously when you're all done, when this is all said and done, you run it, you should get an output window down here. And it's going to be quite a bit of output, right? Don't be afraid to, let's see if I can just real quick grab some. Once you run it and you get this output window, please don't be afraid to expand it so that I can see everything all in one screen here. Don't take 5 different screenshots, all right? Just take, if you can, get everything to fit on this one output window, take an entire screenshot so that I can see the timestamp down here. And then in the results document, don't take screenshots of the actual code. All right, let me demonstrate real quick. I know we're running out of time, but here's an example of the results document that I'm looking for, right? Put the name of the class at the top, what assignment you're working on, the date, and then for each file, I guess in this case, there's only one file. What do we call it? NOAA something. NOAA weather data, I guess. NOAA weather data. And then underneath of that file name, where'd it go? Here, do a Control A, grab all the code, Control C, copy, and then come here to the results document and just paste Control V directly. All right. That way I could see all of the code directly. I'm not looking at 10 different screenshots to look at the code. All right, that shows me all the code. Then at the bottom here, this is where I want the screenshot of the program running with the timestamp. So for that, this is where I want the screenshot. Make the output window as big as possible when you run it so I can see everything. And then launch the snipping tool. Hit the snipping tool and basically say new full screen snip. Bada boom, bada bing. Hit copy. Go into the Word document and hit Control V, paste, and boom, I have everything that I need here. All right. So that is what I want the results document to look like. And then at this point, what I would suggest is saving this results document. Where is it? Under Documents, NetBeans Projects, right? This is where all of your projects are stored by default. Go into your proper folder. What is this? Week 1 assignment. And I would say create a results folder here. Results folder here. And put this, yeah, J. Lusby week 1 results doc there. Hit save. And then the last thing in that documents folder, this is why it's important to name these guys really descriptive names so that you can find it again. In this results folder, do me a favor, copy the actual Java file, just in case I have any questions. For whatever weird reason, I can't really, the results document doesn't look good or whatever. Paste that in there as well, and then send these to a compressed zip folder. Probably better to call it something like this. Week 1 assignment, right? Isn't that what we're doing here? Assignment. All right. This is what I want you to submit. This has both of these files inside of it. All right. Ultimately, I'm probably, hopefully, only need to look at this. But if I have any questions, I've got this as a backup to fall back on. All right. Please submit this through the classroom. And easiest way to do that is to log into the classroom here inside of the virtual desktop, right? Because that zip file, all that work we did is all on the virtual desktop. You're not going to find it on your computer. So go into the classroom here inside of the virtual desktop, scroll down here to week 1, wherever this, yeah, wherever assignment. And then, right, there should be like a submit button or something down here. It's not going to show it for me. But there's a submit button down there where you can submit that zip file and do that in the virtual class. Do that in the virtual desktop in the classroom, and your life is easy. All right. Whew. All right. Wow. Lots going on here. I'm hoping that you all still continue to find these webinars useful. That's basically it for week 1. Please continue to provide me feedback via email, comments, likes on the video, whatever. That definitely helps me make these webinars better, and I really appreciate it. Okay, so with that said, I'm going to go ahead and stop the recording, and I've got a few minutes left for those of you that are here if you have any questions. Okay, have a great week.